Dilution. Dilution is when we take something that is a higher concentration and we add water or something else to it to make it a lower concentration. We do this in our daily lives, like for instance, when you wash your dishes, you don't put, or at least you shouldn't put, the soap, the detergent directly on your dishes. You fill up your sink with some water and you give a little squirt of detergent in there and you dilute out the detergent throughout the water. Same thing if you're doing your laundry. You don't pour the soap on the clothes and just rub it in and call it a day. You actually have to let the washing machine fill up, and then the soap is in there and it dissolves and disperses and becomes much less concentrated. Now, when we do dilutions in chemistry, we have an equation that looks like this. And this is concentration 1 times volume 1 equals concentration 2 times the volume 2. And so the way it works is we get our chemicals, they come in 4-liter containers, which is roughly about a gallon, and it's concentrated. We need to have it concentrated because it doesn't take up much room when it's concentrated. Now, this might be 12.0 molar, which is very concentrated in, say, HCl. And for lab, maybe we need 450 milliliters of 0.100 molar solution. That's how much we need for lab for that day. And so what we do is we go and we find our 12.0 molar concentrated HCl, hydrochloric acid, and we pull out a small quantity and we mix it in a beaker until we have 450 milliliters of solution. We add water. Now what I need to know is how much of this 12 molar HCl do I need so that I can dilute it out to 0.100 molar. So the way we're going to do this is we're going to say that this is either C1V1 and that's C2V2, or this is C2V2 and this is C1V1. It doesn't matter which one you pick as being either 1 or 2, just as long as you keep the numbers together. In other words, if you're going to call this 2, then make them both 2. And if you're going to call this 1 with the volume we're looking for, call it 1. Or you can call that 2 and call that 1. And so the way we're going to do this is I want to know how much of the 12.0 molar HCl that I'm going to use. And so, you know what? I'm going to pick that this one is C1 and the how much is V1 in milliliters. And so this would be V2 and this would be C2. I could have just as easily called this C2 V2, and I could have just as easily called that V1 C1. It does not really matter. And so what am I looking for? I am looking for V1, because I don't know what it is. I just know that I need some. All right, so we're going to solve this for V1 and get V1 by itself, which means we divide both sides by C1, and so we end up with V1 equals C2 V2 over C1. All I did was divide both sides by C1. The C1 canceled, and we're left with C1 over here, and V1 is by itself because that's what we're looking for. So all that's left to do right now is to go ahead and just put in our numbers that we have, and we don't have to do anything to the numbers. We can use them as they are. And so let's see, 0.100 molar for C2, and we got 450 milliliters for V2, and then that's all divided by our first concentration, which was 12.0 molar. And what do we get? We get, after I put it in my calculator, find our calculator, and it's 0.1 times 450 divided by 12. And I get 3.75 milliliters. So if I mix not even quite 4 milliliters of this concentrated 12 molar with enough water to make 450 milliliters, I'll have 0.10 molar, 0.100 molar. hydrochloric acid ready for lab to be used by all the students. And so that's how you do this problem right here. So you have a starting concentration, you have an ending concentration, and you want to know how much you're going to use. So you can imagine if this is how much we have to use per semester, and we only use like 3.75 milliliters of HCl every semester at 4,000 milliliters for 4 liters, that's going to last quite a long time and not take up much room. How many milliliters of 2.00 molar sodium chloride solution to make 40.0 milliliters of 0.350 molar solution? Well, this is a dilution, and so our equation is going to be C1V1 equals C2V2. And I want to know how many milliliters. Well, tell you what, I'm going to make this V2, which means this would have to be C2 because we're going to keep the molarity with the milliliters that it goes with. And I'm going to say this one's going to be V1 and there's C1. So what am I looking for? I'm looking for V2. And so I'm going to divide both sides by C2 to get C1 V1 over C2 equals V2, which is what I'm looking for. Now, don't have to change any of the units. Leave it in milliliters. If it was in liters, we'd leave it in liters. Just needs to be in molarity or percent, actually. And so let's go ahead and plug in our numbers. So we look carefully up here. We see C1 is 0.350 big M molarity, which means moles per liter. And then that's times 40.0 milliliters. And then we're going to divide the whole thing by the original concentration, which was 2.00 molar. And now that's what we're going to put into our equation. And so what do we have here? 0.350 times 40.0 divided by 2.00. And I get 7.00 milliliters. 00 milliliters of the 2.0 molar solution. And so if we take that 7.00 milliliters of the 2 molar solution and we put it into a beaker and top it up to 40 milliliters, we will have 0.350 molar solution after we're done.